explain what TEX-BREIN is. And it's a European cluster project founded by the Interregional Innovation Investments Instrument as part of the European Regional and Development Fund, focusing on capacity building for innovation of textile ecosystems in Europe. There are 8 project partners in 6 European regions, and the partners are Clutex, which is the project coordinator, and Siri from Czechia, Citev and Proditec from Portugal, Piotr from Poland, Textile Cat from Spain, University of Borås from Sweden, and the Next Technology Tecnotessile from Italy. And the aim is to build and strengthen innovative and resilient value chains and support the circular transition of European textile communities. The objectives are foster interregional collaboration among different sectors of the quadruple helix and support upskilling and increase textile circular solutions in less developed regions. And this will be done by development of cross-border cooperation plans for textile SMEs and transfer of textile recycling hubs models. In the upcoming 1.5 years, you will see a lot of TEX-BREIN activities, such as learning expeditions to interesting textile areas in Europe. SMEs will have the opportunity to develop their ideas to applications for funding, and more webinars and workshops, and a couple of rehubs will be created. So here you can see our previous webinars. If you happen to miss any of them, then you can go to the project website and watch them. The next webinar will be held after the summer, starting September 9th, and will be about how to expand lifespan of textile products. But today we have speaker Luca Montemoli with us here, and he will speak about high TRL technologies for circular textiles. Luca is a mechanical engineer at Next Technology Tecnotextile with a master's in mechanical engineering from the University of Florence. He brings hands-on experience in advanced engineering processes, mechanical design, 3D printing, and CAD/CAM modeling. From 2018 to 2024, he worked in R&D and also taught STEAM subjects at ITS Prime Tech Academy. So Luca, hello, and I will leave the floor to you. You can share your presentation. Perfect.
Okay, so thanks, Amelie, for your introduction, and good morning to everyone. And welcome to today's webinar on interview of high technology readiness level for circular textile. I'm Luca, and I'll from Next Technology Tecnotessile, and I'll guide you throughout the world of TRL levels. We will explore what high TRLs mean in the context of circularity within the textile industry, and why they are so crucial for a sustainable future, and look at some technology and product at different TRL level. The textile industry is at a pivotal point, facing immense pressure to reduce its environmental footprint and looking for more sustainable practices. So ITRL innovation are the key to unlocking the true circularity. So before we start, I want to spend a few words on who we are. Next Technology Tecnotessile is an Italian research center established in Prato in 1972. And Prato is one of the largest and most important textile districts in Italy and Europe. And the research center is owned for the 30% by the Ministry of University and Research, and by the other 60% by textile and machinery textile industries of Tuscan district. NTT represents a reference point for research and technological innovation in the textile sector, and is actively involved in a research and demonstration project at national and European level, mainly focusing on circular economy and sustainability in the textile sector. We also offer consultancy services on textile technology, from raw materials to final product, and we support companies in the technological transfer. We also have a specific division for mechanical design and prototyping, and another one entirely dedicated to life cycle thinking, like LCA, LCC, all social LCA. We also have an excellence and quality center laboratory, which offer consultancy, quality control, and testing services for several companies of the territory. Where we are. Let's briefly acknowledge the problem. For too long, the textile industries has operated on a linear take, make, dispose model. And this has led the immense environmental consequences, tons of textile waste, excessive water and energy consumption, and use of harmful chemicals. So the urgency for a truly circular economy in textiles has never been greater than now. And we need to move beyond the simple recycling to redesign our entire system. Sorry. What are the technology readiness level, or TRLs? How do we assess where technology stands in its journey from a brilliant idea to a widespread solution? That's where TRL comes in. This is a standardized system, typically ranging from TRL 1, which is the basic research, all the way up to TRL 9, which signifies a technology that is market-proven and ready to be spread among the industries. TRLs are crucial because they help us to make informed decisions about where to invest, about assess risk, and to understand the true scaling potential of an innovation. They start, as I said, from TRL 1. That is the genesis of an innovation, where the basic principles are observed and reported. Then we have TRL 2, where we formulating this concept. Here is where the theory starts to take shape. TRL 3 is where we proving the concept through physical or analysis or experimental studies. Then we have TRL 4, that is a laboratory validation. So the technology passes from the theory to components or mechanical parts. Then we have TRL 5, where we test in a relevant environment what we discover. So components are now tested in conditions that are similar to reality. TRL 6 is a prototype step. So we have here we have prototypes that are tested in relevant but also controlled environments. From 7 to 9, we can identify the zone as a high TRL. So TRL 7 is nearing a full operational capacity prototype. So here the prototype is tested in actual operational scenarios, and it's almost ready for the full-scale deployment. TRL 8 it's where the technology is now fully formed and tested, and it's really ready for the real-world debut. So at the end, we have TRL 9. It is the highest TRL level. And once you reach the TRL 9, the technology are successfully bridging what is often called the valley of death. So where the difficult gap between the promising lab results and the viable market product. But why they are so important in circular textile? First of all, because the scalability. So we need solution that can move from a small application to mainstream adoption. All the project should not end with only with a prototype, but we need to scale up and obtain a real machine. So secondly, we have economic viability. For widespread change, this technology must demonstrate a clear return of investment. Then we have risk reduction. By being proven, they de-risk adoption for large industries. So we could say that the higher the TRL is, and the lower is the risk will be. Finally, we have a tangible impact. because high TRL technology are the ones that can deliver real and measurable social benefit at large scale, that moving us towards a truly sustainable textile future. Let's focus on some real case studies. And into the circular textile world, we can identify 4 main fields of innovation: mechanical recycling, chemical recycling, innovative materials, and business model and system. Let's start with the mechanical recycling. When we talk about mechanical recycling in textile, we are referring to processes that are physically break down the textile waste, like cutting, shredding, or carding, to turn it back into fibers or yarns. And it's all about preserving the fiber's integrity as much as possible. Here we have a focus on efficient sorting, because sorting is paramount in textiles recycling, because the quality of the recycled material is directly dependent on the purity of the incoming waste stream. Imagine trying to recycle a garment made in a blend of cotton, polyester, elastane, and it's incredibly difficult to get a high quality and uniform output. So effective sorting is often done with advanced technology like near-infrared spectroscopy that allow us to separate the textile mostly by fiber composition, color, and in some cases even on the presence of solid parts like sequins, button, or zips. And this is a precise separation that enable us to create high-value recycled fibers that can compete with virgin materials. Without a good sorting, mechanical recycling is limited in its application and in the quality of its outputs. So here we have 2 different examples. Daedalus on your left, that is a sorting system developed by NTT as a result of an European project, Regio Grintex. And this is a clear example of a TRL6 machine because we have a prototype that is being tested with real textile waste. And we are now working to developing and to scale up all the system. On your right, we have a much bigger machine, this Valvan fiber sort. And this is an example of we will find in the Prato Textile Lab at the end of 2026. The Prato Textile Lab will be a landmark for the district here in Prato, and it will be led by Alia, that is the Tuscany municipal company that collects the textile waste here. And it will manage around 30,000 tons of textile waste per year. Here we have a short video that explains how an entity sorting system works. Unfortunately, I think we do not have the audio, but there are subtitles. So So thanks, Noemi. And let's move to chemical recycling. Chemical recycling in textile involves the breaking down textile waste at molecular level, using chemical processes to extract the base polymers or monomers. Unlike mechanical recycling, which works with the existing fiber structure, the chemical recycling essentially depolymerizes the material, allowing the regeneration of virgin-like fibers. But why chemical recycling is so important? Because it offers several key advantages. It can process textile blends that are notoriously difficult for mechanical recycling, such as polyester cotton or cotton elastane mixes. It may also have as output material with a much higher quality, like virgin material, meaning that they can be used for a wider range of application without significant downcycling. And this is crucial for creating a truly circular system where materials retain their value. Here we have two different examples. On your left, we can see an example of a TRL5 process that we developed into the Redol project. And this is a thermochemical pre-treatment on a pilot scale to selectively remove elastane fiber from bicomponent textile, like polyester elastane, polyamide elastane, and so on. And the result materials of this process, of this treatment, are the pure fiber of the initial mixture and the scraps of solid elastane. On your right, we have the Andritz process that is slightly different because this process or process like this usually have as a result a new yarn obtained by chemical treatment, of course, of the chemical materials in the textile waste, and the other part is the recycled yarn made with other fibers of the starting compound. And this is a TRL8 or TRL9 chemical recycling system, because we start from textile waste, and at the end we obtain the new textile. Here we can say that it's not all about recycling. It's even about the design for circularity from the beginning, with innovative materials or by developing new treatment. Here we have two examples of product to be applied on textile or on surfaces, and all of these products have the goal to enhance specific properties of textile. Here we have a product that has been developed into Text for Future project, where we are a partner. And this is a bio-based formulation to be applied on textile fabrics to reduce microplastic release during the domestic washing phases. Meanwhile, on the other part, we have the Sanox. Sanox is a product to be applied on surface like internal part of ambulances. And the surfaces treated with the Sanox are activated by UV light or with sunlight. And once activated, the Sanox stops the growth of the bacteria and viruses by using a photocatalysis-based process. This is a TRL9 example because it's currently used by ambulance constructor here in Prato and nearby, and it's one of our patented solutions. As I said, IQRL doesn't just apply to innovation in material and processing. It also extends to business model and systemic solutions that are crucial for creating a truly circular economy. Here we have a focus on innovating approaches to the product ownership. For instance, product as a service or PaaS model are gaining traction. Because this means that shifting from simply selling a garment to providing the functionality of that product, like rental or subscription services. And the company retain the ownership and promote the design for durability, repair, reuse, or recycling. Another key area, especially with the involving regulation, is the APR, extended producer responsibility. This is a policy principle where manufacturers and producers are given significant responsibility for the treatment or disposal of the post-consumer product. This means that the brands will be in charge for collecting, sorting, and manage the end of life of their product. We also have the DPP, so the digital product passports, that are moving rapidly from the concept to ITL to reality, because DPP is essentially a standardized set of digital information about a product that they are stored and free for every customer through a digital courier like a QR code or whatever. And for textile, it can contain details on materials origin, manufacturing process, repair instruction, dye process, or recycling of its recycling potential. And this transparency is crucial to enabling traceability and ensuring that materials are correctly sorted and recycled at the end, their end of life. So we must acknowledge the challenge before end this webinar. So scaling this high TRL solution requires significant investment. So we need substantial capital. We also need to build robust facilities for collection, sorting, and recycling globally. We need supportive policy and regulation that are vital to create an enabling environment. And finally, we need the customer adoption and a shift in their mindset are crucial. All of these demand require for sure a collaboration across the entire value chain. So let's summarize all of what we have said today. So high TRLs are essential, the essential bridge from the pilot project to a truly circular textile economy. Investment and collaboration are not just buzzwords, but they are crucial for scaling this innovation. There are many innovations that are already demonstrating the commercial viability. And yeah, the future of the textile is circular. And it will be driven by those ITRL technology and those guidelines like APR, DPPs, or eco design, REACH, and so on. So thank you very much for your attention, and I hope this overview of ITRL technologies has given you a clear understanding of the importance of ITRLs in circular textiles. And I'm happy to open the floor for questions, and yeah, please feel free to ask.
Thank you very much for your interesting presentation, Luca. I can see we have some questions here in the chat and also in the Q&A. So the first one, do you have any high TRL cases for AI in the use of DPP in the post-consumer value chain?
Of AI? Yeah, by now we do not have so many examples of TRL, of technology that involves directly AI. Not directly, but we can find AI in a sorting process or in many other cases that we can, once you develop new studies, you R&D project, you may use AI, but not only to solve the main problem, but to solve side problem that can help you to find the real answer.
Yes. And then we have another one from your presentation. What solvent are you using to remove the elastane in the Ridol?
Unfortunately, I think I can't answer to this question.
Unfortunately. Okay. And then a question about the entity mechanical recycling system. You are now at TRL 6. How long time will it take to TRL 9? And which next steps are you planning?
So that's a good question. Usually we do not have a standard timing between one level of TRL to the next. It depends on many things. It depends on the technology. In the case of our system, we are now developing the industrial machine. An industrial machine, it's not only it must follow some rules and must follow some specs that are strictly connected with the customer needs. So we have to improve the feeding of the textile waste to the sorting system, and then we have to work with the last part, so the real sort part, where we have to divide each garment that we have sorted. So maybe I think in 1 year we may have a much bigger machine, but it depends on, once you do an R&D project, you never know where is the real end of that project. So maybe 1 year, or maybe more or less.
Okay, thank you. And here is another one. Is it possible to express the shift in TRL? From what level is simply providing the goods, and what level is the shift to, for example, renting textile?
Yeah, the same as before. It's not. I want just to share again my presentation on the slide where. Just for. Here. So, as I said, as if you want to rent, for example, a garments, or you need a solid structure behind, like we can do a parallelism with a DVD rental, like Blockbuster. They have big. It's not so easy like rent a DVD with garments. You have to clean it before and after the rent. You have to be sure that the garment is still good and still wearable. So I think we can start to see something like this in a TRL 7 or maybe higher.
It's more processes to consider.
Yeah.
Yes. Okay. And then there is more questions. Let's see in the Q&A. Yes. How long does it typically take to move from one tier level to the next?
Yep. As I said, that's not a standard time. It may be, in some cases, it may be, especially on low tier level, like 1, 2, 3, it may be less time than from the timing between 7 to 8 or to 6 to 7. Once we move from laboratory to the industry, this is the real challenge, when you have to follow not only your rules, but even the customer rules, the market rules, where you have specific laws to be attended. And so I think once, if you can, you can imagine that you can need a TRL 2 to 3 or 4, and then you may need a year or something like that from the higher TRL level.
Yes. And maybe the last question here. How are new regulations impacting research in the textile sector?
Oh, I lost you for a second.
Yes. How are new regulations impacting research in the textile sector?
Okay. Yes, I think in the next 5 to 10 years, the textile sector will be affected with the DPP, APR, and that in addition to, as I said, the REACH and eco design, I think those 4 laws will be, in my opinion, the role model for the textile industry. nowadays we are looking for recycling process, both mechanical or chemical, in order to treat the big amount of textile waste that come from fast fashion. But if we look to our future, I think all of our R&D projects must be driven by the material that we could find in the textile waste of the future. So we need to know exactly, for example, the PP, the exact composition of each garment, or the dye process, or and we must start into developing garments, and the garment is fashion guided, so we have to find a way to start create a new, with the big brands. They start to using eco design, I think, in a very good level, when they start thinking about to not only to project a new garment, but even to how to disassembly. So, for example, if you have a leather patch on a cotton T-shirt, you can add zips or something to easily disassembly that part. And I think it's the most important things to keep in mind for the future.
Yeah, I agree. It's fun to see so much questions in the chat. Here is also one from your presentation. Can your sorting system identify and classify reusable garments?
This is a really good question, because what is a usable garment? Of course, if it has a hole in it, of course, it may not be usable, but it may be a fashion reason. For example, we can see jeans with a hole in it, or they are all. So I think this one is a clear example of where AI must be maybe really, really useful, but it's really connected with the fashion world. If I have a T-shirt, a plain white T-shirt, and without holes, without anything, I think, okay, 90% of the time it's maybe good. But I also see people with a plain white T-shirt with holes in it, or so I think it's easy, but not so easy to sort, and to even not so easy for us to say that okay, this garment is useful or is usable or not.
Sometimes it depends on the customer.
Yeah.
Yes. Okay. Thank you very much. So maybe you can see my presentation again. Yes. So I think we are we can finish here. Thank you so much, Luca, for your presentation, and for everyone listening today. And here are some contact information if you would like to reach us afterwards. Enjoy the rest of your day and summer holiday coming soon, and see you later in September, hopefully. Thank you, everyone.
Thank you.